Welcome to the homework help video for the extra problem number 1 from the 2.1.1 homework assignment. Occasionally we like to add in some problems with some repetition and practice, and that's why it kind of has a different number than the rest of them. But for number 1, it says, simplify each expression as much as possible. Starting out here, we're going to look at some stuff with exponents. So, letter A, you see we have -2, and it's being raised to the second power. So remember, this simply means, right, that we're taking a -2 and we are going to multiply that times another -2. So the base here is -2. It's being multiplied times itself. And we know negative times negative is going to be a positive. So -2 times -2 is going to give us +4. And that is our answer. Now when we look at letter B, B is saying 2 squared. So this simply means 2 times 2. Our base on this one is a +2, and then we know that 2 times 2 is going to give us 4. So we actually get the same answer for A and B, right? Because when we multiply a negative times a negative or a positive times a positive, we still get a positive. Now C is where people start to have problems. When we see a -2 squared, you have to think about that as being something like this, okay? The base is just 2. This is the equivalent of saying -1 times 2 squared, right? Or you could say -1 times a 2 times a 2, in which case we know that -1 times 2 is going to be -2, and then times 2 would be a -4. So that's really important that we're able to notice the difference between letter A and letter C. Okay, and if you type them in your calculator knows that as well and will follow the order of operations. It's thinking about PEMDAS as being, I'm going to do the exponent before I do the multiplication, which is the correct way to do it. So when we look at letter D, on letter D we have the opposite of 3 squared, right? So this is like saying a negative, and our base is 3. So this is like saying a -1 times a 3 times a 3. Well, we know 3 times 3 is 9, and then times -1 should give us a -9. Okay, we're letter E now, right? Letter E, we've got our base is -3. So this one's very similar to letter A, where we've actually got a -3 times a -3. Negative times negative is positive, and 3 times 3 is 9, so our answer is +9. Letter F, we've got 3 squared, so in this case here, base is 3. This is simply 3 times 3, which is going to give us +9 as well. And down below, we just have some practice with simplifying radicals. Remember, with these ones, we are looking for perfect square factors, or if you don't see those there, then you're welcome to use the factor trees to find the pairs of factors. Okay, maybe I'll demonstrate that here with 76, right? If I took 76 and I broke it down, I know 76 is the same thing as 2 times 38. 38 is the same thing as 2 times 19, right? And 19 is prime, 2 is prime, and 2 is prime. So really this is the same thing as saying the square root of 2 times 2 times 19. Well, 2 times 2 is really the same thing as 2 squared times 19. Or some of you may write it as 4 times 19. Doesn't matter, whichever way you want to write it is okay. But either way, this is the square root of 4 times the square root of 19, and we know the square root of 4 is just 2, so we get 2 times the square root of 19. Okay, so looking at h, you have 180. So we're taking the square root of 180. And again, if you're not sure what perfect square factor goes in there, you can take it and look at it like this, right? 2 times 90. 90 is 2 times 45. 45 is 3 times 15. 15 is 3 times 5. Now those are all prime numbers, but you'll see here that we've got 2 squared times 3 squared times 5, right? Because we have 2 2's, we have 2 3's, which is the same thing as 2 squared and 3 squared. Okay, now if you want to change them to 4 and 9, that's totally fine, right? This is the same thing as saying 4 times 9 times 5. Or some of you would rather leave it as 2 squared times 3 squared. That's okay too. But when you break it apart, we've got 4 times 9 times 5, each in their own square root, which gives us 2 times 3 times the square root of 5, or 6 times the square root of 5. Okay, now some others of you may look at this one, and instead of doing that, you may just be like, hey, I can figure out what perfect square goes into this. Since we got 6 out, if we square it, we could put it back in. We could think of this as just being the square root of 36 times 5, because 36 times 5 is 180, and then break it apart and get it that way. Both ways are correct, so it doesn't matter which way you do it. Okay, you're going to get the same answer as long as you understand the method that you're using. And then we're on to the last one, letter I, right? We're just breaking down the square root of 8. Well, we know the square root of 8 is the same thing as 4 times 2, which is like the square root of 4 times the square root of 2. We know the square root of 4 is the same thing as 2, so we get this 2 times the square root of 2. And that is the answer. So if you have additional questions or need some extra help or practice on any of these, please make sure you reach out. This is that extra problem number 1 from the 2.1.1 homework.